Entropy is an inherent quality of the universe. It links melting ice and messy rooms. How? Let's find out. These blocks of ice have a nice defined shape. They have a tightly packed tetrahedral structure and you can hold them easily in the palm of your hand. Now this is water. It doesn't have a very well defined shape, nor does it have good structure. But it can still be distinguished from its surroundings. This is where the water is, this is where it's not. But water goes crazy when you boil it. You can see it trembling in the vessel and some of it is escaping as steam. Now steam is still water. Its structure is the same as that of water, but can you see the steam anywhere? The steam is still in the kitchen, but now it has blended with its surroundings. It has adjusted itself into the air that's in the kitchen. If we were to take a sample of this air, we would not be able to tell right away where all the water is. Its position has become unpredictable.
Two things increased in this demonstration. One, the temperature. Two, the randomness of the water. Randomness is quantifiable. We call it entropy. In technical terms, entropy is defined as the measure of the randomness of a given system.
Now, here's something you can see around you. Mess. Mess is a form of entropy, and the best place to see it is in a room. Entropy has a very special quality. It's irreversible, or at least it cannot be reversed without putting in extra work derived from another system. In the case of my messy room, the work done to reverse this mess will be derived from me.
Soumya, clean your room.
My room had been one system. The block of ice we saw earlier was another system. In this way, anything can be a system. My room, this house, this trash dump. Imagine the work required to reverse this entropy. And bigger things. Earth, our solar system, our galaxy, even the entire universe. The universe has a tendency to move toward disorder. And seeing as my room and the ice cube are a part of this universe, they too will move to a state of higher confusion. Entropy can be described using three laws of thermodynamics, 0, 1 and 2. Law 0 of thermodynamics states that if a system A is in thermal equilibrium with a system B and system B is in thermal equilibrium with a system C, then system A has to be in thermal equilibrium with system C. Okay, in terms of this house, it means that if the mess in my room is the same as the mess in my parents' room, and the mess in my parents' room is the same as that in the kitchen, then the mess in the kitchen has to be the same as the mess in my room. It's a simple case of if A equals B and B equals C, then A equals C. Law 1 of thermodynamics takes a bit of time to explain. According to this law, the energy given to a system is used to increase its internal energy and to do work. My room was the type of system that could not change its volume, and work requires change in volume. So any energy that would be given to my room would have just increased its entropy. Maybe it would just have randomized the particles of air, but that would be enough. That's what this law means. Law 2 of thermodynamics can be said in two ways. Entropy can never decrease, or heat can only flow from a system of high temperature to a system of low temperature, never backwards. We've seen this before. The entropy of the ice cube increased with temperature. After having turned the ice into steam, it would be hard to turn it back into ice. So entropy can be reversed, but at the expense of another system. So what does entropy have to do with our life? Let me ask you this. How many times have you had to boil water in order to cook something? How many times have you worried about making or cleaning up a mess? It's all entropy. And last but not the least, it's a perfectly sound excuse not to clean your room.